Thank you all for coming here. It's a great honor to be here. I'm super excited to be giving this talk, and a huge shout out to everyone from Heapspace and all the volunteers for making Vox Days so fun. The past 2 days have been great, and I hope that we can end today with a bang, and tomorrow and tonight the party. I'm sure it's gonna be great. So to get started, can I get a show of hands how many people in this room are JavaScript developers, or at least, work with JavaScript? Okay, awesome. So how many of you have actually written some code with Redux and stuff? Okay, a bit less, but awesome. So let's get started. So the title of my talk is Complex State Handling in Modern Web Applications. And as I pronounce that, it seems like quite a mouthful. It's only 6 words and a capula between, but it's sort of distracting. It's full of some buzz and noise, and as a programmer, I really like to optimize these things. So if I had to choose an alternate title, I think it would be just state, because that's what we've all come here to listen about. And I don't think I need to explain too much about it. The lower part is kind of redundant. I don't have the foresight to talk about the future. Well, not yet at least. And the idea of a complex web application and a complex state is maybe somewhat subjective. It depends on your experience, your level of knowledge, and the current tools you're using. We don't really have a quantifiable metric for that. So why state? Why did I choose to give this talk anyway? Well, state is something that I'm sort of passionate about. It's something that I really want to spend the next 40 minutes talking about. And this is because managing state is a large part of what we do as programmers. Most of the challenges and the problems we work on relating to our application state in some way or another. And as such, it's important to talk about state because I feel that managing state is hard. It's pretty difficult, and sometimes it's inherently difficult because the problems we are solving are hard regardless of the levels of abstractions that we can think of. And I've identified what I consider to be 2 major challenges. The first is that state changes over time. And this seems like something pretty basic. It should be something of a basic property of state. Obviously, we want it to change. So why is that a problem? Well, the problem comes in the fact that these changes come in various intervals. They come in various magnitudes. And if we don't have something that solves this in a predictable way, something that's easy to handle, we might be in a bit of a problem. And in fact, a lot of authors will agree that maybe the fact that state changes over time is the root of all bugs, or maybe you can even say the root of all evil. So that's the first problem, but the second problem in state management is that async is also kind of hard. It comes with a lot of challenges, and it's maybe a bit of an elephant in the room. It doesn't appear like it's something that's so difficult, but as you go and develop projects and apps become more complex, you notice that you maybe don't have the proper tools or methods to solve these issues. And sometimes those problems are just inherently hard because of the underlying business logic or the data model behind it all. So those are the 2 things I'll be talking about. A bit about myself. My name is Danic Filip. I'm a software engineer at Spice Factory, and we are a digital product development agency that helps businesses in the digital transformation. We love to work with startups and enterprise clients, and we love developing products from scratch. We like to be there from the early validation part and all the way to shipping to production. And we shipped quite a few apps this year to production that use Redux. And we have, learned a lot of things. And this is the experience and the knowledge that I'm hoping I can share with you today. What you see here is a little illustration of me that was done by our digital artist. You can only see my head sticking out of the laptop, but next to me is this huge pile of coffee mugs. And this is kind of something that I've noticed, that when you work with JavaScript a lot, you tend to develop certain addictions. Mine was coffee. Some people, they do some harder stuff. So my promise is that by the end of this talk, we'll see how we can make our states easier to reason and simpler to manage. Maybe the problems themselves will still stay hard, because it's really very difficult to get something from hard to easy, but easier as opposed to complex and simpler. That's what we're going to go for, and I hope that you will leave this talk looking kind of like this guy over here. So, Redux. Redux is a predictable state container, and it was developed by Dane Abramov. I'm sorry if I mispronounced that. And he's a terrific guy. He's done a lot of work in the React community especially. And it was inspired by two things. The first is the Facebook's Flux architecture. It takes those concepts and builds a lot on them. And the second one is Elm and their sort of model view update. And the great thing about Redux, apart from the fact that it is predictable, and we'll see what that means, is that it's completely view agnostic. We saw a talk earlier today showing us how we can integrate it with Angular. We can use it with React and a lot of other stuff too. So Redux, predictable, deterministic, has flows, data flows that are easy to follow, and the whole thing is very easy to reason. But you might be asking yourself, wait, but why? And in JavaScript, a new framework comes out every, 2 weeks or so? And it's hard to keep track of it. Why is Redux special? And I hope we can get into these reasons now. So, first of all, it's a pattern. It's not a giant framework. It's a very small library. You could probably spend an evening going through all of the code and the docs, and it will kind of make sense. And just like Flux, it is more a philosophy, if you will, a pattern. And what Redux really does is it teaches us how we can compose reducers, action creators, subscriptions, event emitters to manage our state. And two great things. It's easy to integrate into an existing project, even if a project is, just starting out. There's a lot of boilerplates out there that are really cool. And it's easy to integrate bit by bit into an existing application, so that's pretty great. But something that's also great, and that time might come, is when you want to ditch Redux. And this is great because as long as you're ready to migrate to something else, Redux itself is very easy to eject from the application. You're not really marrying into this complex family of other frameworks when you choose Redux. So that's pretty great. So Redux provides a single source of truth. And when talking to other developers, I've noticed that this is kind of like awesome. Everyone likes this idea of having a single source of truth. With Redux, that basically means we have one store, a single store, and we have this one large state object. Now, to some people, that might not initially sound like a great idea, because if you're coming from Flux, for example, you aren't limited to a single store. You can have multiple stores, and they also make it easy to split your code, write meaningful tests and stuff. So that's not what we do in Redux, but you get the same thing, the modularity, the code splitting, because of reducer compositions. And we'll see how that looks like. In terms of memory and performance, there's no issue with using a single store. It runs very well, always. And with a single store, we also get the benefit that it is very easy to persist, it's easy to hydrate and rehydrate, and reading from the store is extremely easy, especially because there are certain selector libraries that make it easy for your smart components to just subscribe to the data that they need for their presentation layer. So Redux is deterministic, and it comes with this predictable unidirectional data flow. So the first block is actions. Actions sort of describe what just happened. Reducers are responsible for taking these actions and modifying the store, and we'll see how that works. And finally, we have views, which are basically subscribed, and they listen to the changes in the store. And it's pretty simple, when you see a flat diagram like this, it's very easy to follow, very easy to understand, and most importantly, very easy to reason. So what about updates? What if this view wants to update the store? Well, it goes through this same flow. It dispatches a new action, the action goes through the reducer and updates the store if needed. The view is then subscribed to those changes. And this is very similar to the model view update that's used by libraries like frameworks like Elm, where model equals basically state, and it's basically unidirectional, except here it's shown as a little connected graph. And moving on, another great thing is immutability. Oh boy, immutability in JavaScript, that's pretty difficult. Well, at least in vanilla JavaScript, because there aren't really any proper methods inside of JavaScript itself to create immutable objects. You can use const, for example, but that doesn't stop you from adding items into an array or changing the keys of an object. You can use something like object.freeze, but even that has some downsides. But we'll see that it's not that hard to achieve immutability, but what I also recommend is just not trying to achieve immutability with vanilla JavaScript. Instead of choosing to use a library like immutable.js, it provides maps, lists, immutable collections, and has a very an API that's very much great for people who are into functional programming. And what we'll see is that really everything is just functions. It's easy to chain reducers, it's easy to apply middleware, enhancers, and when you try and make a realistic example in React, it all sort of clicks together and makes sense. But I think I've been talking a lot, so maybe this is a bit too abstract. You're maybe like this. Sorry, but I'm not listening anymore. So maybe we can look at some code examples and a demo, and maybe then we'll have that click moment. So actions. The function here is not an action. It is what we call an action creator. The action itself is this return object. And the most important thing about this return object is the type. It's a string of some sorts that describes what this action is telling the state. We can have additional payloads. So for example, this function apparently, it provides some products to the state, products and timestamp, probably for caching and stuff. But, those parameters are optional. We can have actions with just a type. And we can write this a little lighter if we want. We can just simply always decide on a convention to use payload object and not worry about the ordering of parameters. Sometimes actions can get pretty big. Not everybody does this, but it's good to, at the start of a project, just agree on what you're going to do and keep to the pattern. It's also a good idea to not place strings directly in the type field. Better to just create some constants file, and you can even namespace it if you're worried about conflicts. So here we have const get products. It's somewhere in a constants file, and you can import it and just reference it. And when you need to change the name of the constant, you do it in one central place, and the rest of the app works just fine, right? So what about the state? How do these actions actually change the state? And what we have here is a function signature. How many people are familiar with functional programming? Awesome. So this is the right talk to be then. So new state is not a mutation of our previous state. It is a new object that results by applying an action over the previous state. And this function signature is pretty much this, a reducer function. So our new state is when we apply the previous state and an action through a reducer function. Okay, so what does this reducer look like? Well, here's one example of a reducer. You can structure your code in various ways. A lot of people use switch statements, and so they switch over the type of the action, and they return basically the new state. So here we see that the first argument is the state itself. If the state is currently undefined, we can assign the initial state. And the second argument is the action, switching over the action type. What we're doing here is we're returning a new object using object.assign. So we're basically copying the state, and we're setting new keys. So we're sort of copying and applying mutations and returning this as a new state. And this gets pretty messy because when you're working with objects, you're using stuff like object.assign. When you're working with arrays and collections and stuff, you have to use a lot of stuff like concat and similar stuff. And that's not very easy to reason, I feel, and the code can get pretty long there's a lot of cognitive overload. So maybe we could use something like Immutable.js. So it's a very light library that provides you with immutable structures like maps, lists, ordered maps, sequences, a lot of great stuff. And it comes with a bunch of these methods like set, setin, get, update, update in, and you can chain this with, usual methods that you're probably used to in functional programming, like map, filters, reduce, and stuff like that. And so we've replaced this block of code with something a lot more elegant and easier to understand. State is now an immutable object, and we're calling set 2 times to set these 2 keys. And what it does is it's not mutating the state object directly, but returning a new object. Great. So the store itself, pretty easy to create. In the most basic sense, it's just a variable that is the result of a function called createStore. It's provided by Redux, and it accepts 2 parameters. The first is the reducer, and the second is the initial state. So this immediately raises the question, well, hold on, do I really have to have a giant switch statement with a million types? And well, no, we can split our reducers into various codes and use something called combineReducer to basically merge all of those reducers into one reducer and pass that as an argument instead. All right, well, what about middleware? I want a logger middleware that shows me all the actions. I want something for my async operations. How do I inject that into the store? Well, really easy. We can use compose and apply middleware. It's another argument that we can pass to createStore. And what this is basically is middleware is an array of functions like saga middleware and logger middleware. And we're using compose along with apply middleware. This is a cool little feature in ECMAScript 6. And we're basically applying all of our middleware in this step. Pretty cool. So it's all very easy to reason. It's predictable. So what you should totally be doing is writing tests. And when you do a lot of code splitting with your reducers, it makes it very simple to extract all of that logic and write functional unit tests. So this is just an example of a test that's testing if the products reducer handles this action correctly. All right, pretty easy so far. But maybe some of you are feeling like this, you know, what in God's name is he blathering about? So maybe it's time we, you know, had a look at a few demos, for example. And I'm going to basically mirror my display. Cool. So let's start with a basic example. What we have here is, oh, let me make that bigger. I hope everyone can see what's going on the screen. So what we have here is a simple little shop, let's say. It has these products like the Voxed t-shirt, Igor's unicorn tears, and some steampunk goggles. And we can add all this stuff to our cart and check out when we're finished shopping. Now, what I have here on the right side, left side of the screen is something called Redux Developer Tools. It integrates great with Chrome, Firefox, I think Safari as well. And it's basically like this middleware that's going to be listening in on all of the actions as they happen and allow us to inspect. Is that better? Okay. So unfortunately that made this part here also a bit bigger, but it's not yeah, it's not responsive and it's not really important. We're just going to be clicking a button so for now. So what happens when I click add to cart? Well, we can see right here that it dispatched this add to cart action, and I can inspect it, and it says type add to cart product ID 1. Okay, pretty good. That's what we were expecting. But how did this actually impact my store? Like, what happened? And what we can do here is we can go to diff, and it basically shows us what happened, what changed, and we can see that, you know, in these green bubbles, something new has entered the store. So let's see what the initial state looked like. We had a cart that was empty. It had these keys, but they had undefined values. And we had this products key that had another key called by ID, which is an ordered map of products. Each of them has their own ID, title, price, and how many of them are currently in the inventory. And when we added this to the cart, our cart got increased. So we added we added our first product with ID 1, and we added exactly one item. So we have one item with ID 1, and in the products part, something changed. So the inventory actually decreased from 6 to 5. So what will happen if I keep adding t-shirts? So eventually they get sold out because our inventory has reached 0. But let's say that some sort of bug happened, you know, somewhere around here, and we want to see why that was. Well, we could do a bit of time traveling. You know, we could skip this action entirely and see what's up with the state. Does it work? Was just that one action corrupted. We could also do a bit of testing. We can dispatch our own actions here. We can just write our own, code and dispatch an action. We can also import and export our state. Really useful for sort of persisting it. You can leave your dump on Jira and some other developer can pick it up and work on it. And they have this really nice visualizer that basically shows, what was happening. It goes step by step through all the actions. That's pretty cool. And finally, we have this area here that's basically updating as I add items to the store. And I'll try to check out, and yeah, we successfully bought $300 worth of t-shirts. So awesome for us. And notice that they're still sold out. Okay, great. Can we do something a bit more complex though? And since I'm asking that, you probably know that I am going to do something a bit more complex, so yay. But a bit of a story first, if you don't mind. So there's this joke in the Redux community that if you repeat Redux enough, Redux, 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 it starts to sound like 3 ducks. And if you actually Googled Redux ducks, you'd end up with a ton of NPM modules, libraries, developer tools that actually embraced this joke. So I wanted to have a logo for my app. I didn't end up adding it into the app itself, but this was my initial idea. So I asked our in-house artist if she could do something better. So she came up with this. And, if we compare these two, you probably didn't even know these were, live vests. But, we can all agree that this is clearly better. Sure. But everyone was like, you're gonna hurt Dragana's feelings if you don't use this. So I decided on a compromise. I will use this if she puts on some Viking helmets on these ducks. And honestly, I think that's far out, They look awesome. So let's look at this demo app I'm talking about. So this is especially not responsive, I'm afraid. So I'm gonna try and walk you through it step by step. So what we have in this tab is a sort of prototype editor. And it comes with all these little components. It basically has 2 components types. One is an image. It loads an image from some source. You can see that on the side here. And it has its standard properties like size and position. And down here it has channels. Alpha channel, grayscale, and brightness. So if you compare that with this component here, which is a simple value slider, it has, a value that you can input and, you can move it around. So what I wanted to do was I wanted to make something interactive happen when you move this knob around. So I created components that basically have this dependency on each other. So the alpha channel, the grayscale channel, and the brightness channel of this image depends on how you use the sliders above. So if I go into another tab where I have this like demo, you can see that it's changing. So if I turn up the grayscale, you do something like this. And the brightness, well, probably best not to mess with that too much. I'm not really artistic, as you saw previously, so I'm not gonna play too much with those controls. And what's what this app is illustrating is a very interesting problem, because the updates are happening live. This isn't a separate store. They're connected. And why is this, a bit of a challenge? Because, we have this tree of components here, and we want to copy it in the other tab, but we also want the other containers to apply its own mutations. Like, we want, when I move this, I don't want it to change over here. And there are a lot of ways you can implement this. There's a lot of libraries. Some of them actually do contain the word duck in them that sort of hydrate the store between tabs. What I ended up going for was sort of a server-sent event approach, where everything that happens here basically dispatches a call to a server, and here we have some channel that's listening on those changes, and that works pretty well. But that makes it for a great introduction to another problem that we have as developers when working with state management. And I think some of you might remember this. Async is also hard. It's also a bit of a problem. So what we had there was a bunch of asynchronous actions happening. I'm editing it, it's going through a server, then somebody else is listening on it through a channel. How do we solve these problems? And there are a lot of tools. For example, you could go with reactive programming, and there was a great talk about it yesterday with Redux.js, and it's pretty cool. I want to show you something a bit more easier. And remember how these guys have Viking hats, or helmets, excuse me. Well, this is because we're going to try redux-saga. And saga is this word that's usually associated with Vikings and their epic voyages of pillaging. So that's why our ducks have helmets from Vikings on them. So what about the simple solutions like callbacks and promises? Well, callbacks, I think everyone's familiar with them. They get the job done, but it's far from elegant. It's far from, something that's more pure, easier to test, and there's always that dreadful flying a V or the callback hell problem. It happens, and it can also be avoided, but it happens. And promises are pretty great. Unfortunately, the standard is way ahead of the implementation right now, because you can't cancel promises in JavaScript, and that's really bad, even though the standard already defines that, and there's a working implementation of it, but it just hasn't been published yet. So how about sagas? And what sagas are? Well, they're nothing new to JavaScript per se. They've existed in software development for years. But since this is JavaScript, a lot of normal stuff becomes new. And what they are leveraging here is generators. They're a new feature. They're basically functions that you can call over. And they don't really terminate until there's nothing left for them to produce as a result. So what we have here is a simple generator called count2n. It basically takes a parameter, a number, and every time you call it, it will return the next number. So first time we call it, it will return 1, second time 2, all the way up to n, in this case 5. And it will always send this key, is it done or not? And when done is true, this function has essentially terminated and left the stack. So here's a saga. It is basically a middleware in our store. And here's what it does. It has this watcher that constantly, while there's a while true there, so this is constantly executing. and it's waiting on either one of these two actions. The first is get all products, and the second is stop. Stop happens in this case when the user navigates away from the page. So they entered the page, they wanted to load all the products, and then they left, and we want to cancel that loading, for example. So here's what happens. If the watcher, stop is true, we break this saga gets terminated. But if the watcher is equal to list, we're basically using yield call to call a product service component that has this method get all. We're giving it some data parameters, and we're expecting some sort of result from this. And if it's an error, we're going to yield a function called getProductSerror. It's actually an action, and it'll go through the same pattern like normal actions. And if the list has successfully been returned, we want to yield this action getProductSuccess with the response, and we assume that the reducer is going to handle that and update the store. Great. So how much control do you have with something like Redux Saga? Well, forks are really cool. I guess a lot of you can already know when this function will terminate. It won't terminate until all of these operations have completed, either successfully or not. So by using fork, we make sure that the saga doesn't terminate early. But you can use something like spawn, for example, if you want certain tasks to run their own saga, or if you want to terminate sagas when certain conditions are met. It's pretty good, especially for more complex and synchronous flows. So what about stuff like server sent events, streams and stuff? Well, here's an example of an event channel. It's also something that really comes with the Redux Saga package. And what we're doing here is we have a function called a notification channel that's returning an event channel with this emitter that will basically emit a new message every time something happens on this event source. If there's an error, in this case, it will just simply close. So how does this all work with Redux? Well, we can create a saga which implements this channel. It yields it, and we can basically say while true, take from this channel every time there's a new message, and put to the store through the dispatcher this load notifications action with this new notification that we have. And that works pretty well. So to conclude this talk and basically open up with a Q&A section if you guys have any questions. This is very simple, this drawing, I mean. And I think we should always strive to choosing simplicity. But that doesn't mean we can't have good things, With Redux, we get the simplicity, we get something that's easy to reason, something that's easy to explain. But we also get a set of tools that really solve a lot of our problems. And that's it. Thank you. So there's lunch going to be served soon, and I bet a lot of you guys are eager to get out of that door and go get a bite to eat. But if you have any questions, I can answer them now, or you can ping me later.
Hi. Yeah.
Hi.
Thanks for the talk. Yeah, I was wondering, it's not a question, it's more like a comment, because you said that you remove complexity, but basically you are using a paradigm, like you are using event-driven programming. and it doesn't remove complexity. It takes on an other level of complexity, because if you don't have your nice debugger, it's very hard to reason about.
Yes, but that's true. And I agree that we can never maybe make problems that are inherently hard simply easy. Maybe we can make them less hard. And I think we can, make it more simpler. We're striving for simplicity here. We maybe won't always reach that level of simplicity where there's nothing complex, but with the proper tools, and Redux comes with a lot of tools that make the whole developer experience very easy. I think it's very easy to reason about those problems.
The tools make it easier for sure.
Yeah. All right. Any other questions? There's a question over here.
Thanks a lot for the talk. Quick question about the sagas.
Yes.
How does the things work behind the scenes? I mean, do they do like browser tasks, separate processes, or?
Right. So you can think of sagas in a way as kind of like a separate thread, even though it's not really a new thread. And they're basically this middleware that lies between the reducers and the store. And what they can do is they can call on other providers. For example, product service here is some HTTP abstraction built exclusively for products. But it doesn't just have to be HTTP stuff. You can do stuff with web workers, do some async stuff with the web cache or local storage and stuff. So yeah, just about anything really. Okay, any other questions? Cool. Thank you all for listening, and enjoy your day.